Hey, Math 20-2s. Today we're going to look at analyzing the graph of y equals ax squared plus bx plus c. So in the previous lesson we talked about a quadratic function of degree 2. It can be written as f at x equals ax squared plus bx plus c, or y equals ax squared plus bx plus c. A, b, and c are real numbers. A can never equal 0, otherwise that makes it into a linear function. Therefore it can't be a quadratic function. Note the graph of a quadratic function is always a parabola. So a parabola has a maximum or maximum point if the parabola opens down. All right. A parabola has a minimum or minimum point if the parabola opens up. All right, so if it opens down, obviously we have a maximum. If it opens up, obviously we have a minimum. The vertex of the parabola is the max or min point. So both these are called the vertex. One has a max, one has a min. All right. The maximum or minimum values of a quadratic function is the y-coordinate of the vertex. Right, so this point will have an ordered pair x and y. In both these cases on the graph, the y-coordinate will either be the maximum point in that case, or minimum point in this case. They're the y-coordinate. Number 1, complete the table of values for the quadratic function y equals x squared minus 6x plus 5, where x is any real number. So again, if I plug -1 in for x, I get -1 squared, which is 1. -6 times 1 is a positive 6 plus 5. So 1 plus 6 plus 5 is 12. If I plug 0 in, 0 squared is 0, minus 6 times 0 is 0, plus 5. That gives me 5. If I plug 1 in for x, 1 squared is 1. -6 times 1 is 6, plus 5. So 1 minus 6 plus 5 is 0. If you plug 2 in, you get -3. If we plug 3 in, 3 squared is 9. -6 times 3 is 18. So 9 minus 18 plus 5. That's -9 plus 5, which is -4. Again, if you plug 4 in for x, you should get -3. If you plug 5 in for x, 5 squared is 25. -6 times 5 is a minus 30, plus 5. So 25 minus 30 plus 5 is 0. You plug 6 in, you get 5. You plug 7 in, you get 12. So we've completed that table of values. Draw a vertical line representing the axis of symmetry on the graph. Number 2. Plot the points on the grid provided. Connect the points with a nice smooth curve and extend the graph. So let's plot those points on this grid. When x was -1, y was 12. That's right there. When x was 0, y was 5. When x was 1, y was 0. When x was 2, y was -3. When x was 3, y was -4. When x was 4, y was -3. When x was 5, y was 0. When x was 6, y was 5. And when x was 7, y is back to 12. So connect those with a nice smooth curve and extend the graph. Do it on both sides. And we've got our U-shaped curve opening up. Draw a vertical line representing the axis of symmetry. So let's do that. A vertical line which will cut this graph exactly in half. So it's got to go through the vertex to cut it exactly in half. And it's going to be this line right there. All right. That's a vertical line. The equation for all vertical lines are x equals. And every point on that line has x equals -3. So the equation of that axis of symmetry is x equals -3. All right. Now, fill the blanks or circle the correct alternative, all the bullets below. So the graph of the quadratic function is a parabola. It's a U-shaped curve. The vertex of this parabola occurs right here. What are the coordinates of that vertex? Well, x was +3. and y is -4. All right. So the equation for the axis of symmetry should have been x equals, not again, x equals +3. This parabola opens up, we can clearly see that, and therefore it has a, if the parabola opens up, it's got a minimum value, or a minimum point. All right. The minimum value of this function should be, according to the definition above, the y-coordinate of the vertex. So our vertex has the coordinates 3, -4. The y-coordinate of that is -4. So the minimum value of this function is -4. The x-intercepts of the graph. Where does this graph cross the x-axis? Well, it crosses the x-axis at 1 and at 5. So those are called our x-intercepts. So the x-intercepts of the graph are +1 and +5. The y-intercept of this graph, it crosses the y-axis right here at +5. So it also has a y-intercept, the point where it crosses the y-axis at +5. The equation for the axis of symmetry, we've written that in green. It's the line that goes through the vertex. It's always x equals, and it's actually the x-coordinate of the vertex. So x equals 3. The domain of this quadratic function, well, it goes forever right and forever left. So x is any real number. The range, we're talking about up and down now, so this graph goes forever up. But it doesn't go any lower than y is -4. So y must be greater than or equal to -4 and any real number. That's greater than or equal to -4. Part 5. How can the equation of the axis of symmetry of the graph be determined from the x-intercepts of the graph? So if my x-intercepts are at 1 and 5, and this graph is symmetrical, axis of symmetry, it's symmetrical. That means for the same y value, these both have y values of 0, right? X-intercept, y values of 0. They have to be symmetrically apart. They have to be the same distance from the axis of symmetry. So my axis of symmetry has to go right between these two x-intercepts. So you can figure out the equation for the axis of symmetry by finding the halfway point between the x-intercepts. Halfway between 1 and 5 is 3. So that's the equation for the axis of symmetry. X equals 3. All right. Using a graphing calculator to determine a maximum or minimum value. So let's verify the calculator window is in a standard setting. You do that by going Z standard or zoom 6. All right. The equation y equals -x² plus 5x plus 14 will be used to illustrate the maximum feature. Enter the equation to y1, adjust the window settings. All right, so let's do all the stuff that it's telling us to do. Let's do it on a graphing calculator. So let's clear everything in our calculator right now. So go to y equals and type in the equation y equals -x² plus 5x plus 14. -x² plus 5x plus 14. And it wants us to go zoom 6, our standard viewing window, zoom 6. That's what the curve looks like right now. Now it tells us to adjust the window setting because we can't see the maximum point on this parabola. So let's go to our window setting and adjust it. Let's make x the smallest value of -5 and a maximum value of 10. And we can go by a scale of 5 according to our workbook. And the y values in the window are -5 to 30 by a scale of 5. And now if I hit graph, now we'll get the same picture we have in our workbook. So to activate the calculate menu by entering second function, then trace, and we're going to look for the maximum point. So let's do that second function calculate, and we're going to go down to number 4, which says we're looking for the maximum point. So you press enter. Now this cursor could show up anywhere on this curve. If I'm looking for the maximum point, it's going to ask us to find the left boundary. So I want to get left of that vertex or that maximum point. So you can use your arrow keys to get left. Once you're somewhere left of the highest point on the graph, press enter, and you'll see a little arrow come up. So now I've identified the left boundary. Now the calculator asks me what's the right boundary. So again, I can move my arrow to the right until I am to the right of that maximum point, and anywhere to the right, doesn't matter how far, and you press enter, and another arrow will come up, and you will now find the maximum value between these two boundaries. It's asking you for a guess. You don't have to make a guess. If you want, you could move the cursor back somewhere near the maximum point and press enter, but that's not necessary. So you press enter a third time, and it gives you the maximum value of 20.25. That occurs when x is 2.5. All right. So we know what the vertex is. If I had to draw this now, the x-coordinate is 2.5, the y-coordinate is 20.5, sorry, 20.25. And that would be my vertex. All right. So we can find the vertex of the parabola by finding the maximum if it's opening down. We do the same thing to find the minimum if it was opening up. All right. On to the next page in our notes then. Consider the quadratic function f at x equals 2x squared minus 13x plus 15. State an appropriate window setting for displaying the graph of this function on a graphing calculator, and then determine the coordinates of the vertex. Explain how to use the coordinates of the vertex to determine the equation for the axis symmetry. Well, let's do parts A and B first. So let's graph this equation on our graphing calculator. Let's go to y equals, clear the one we have there, and type in 2x squared minus 13x plus 15. And if you go zoom 6, zoom standard, zoom 6, our standard viewing window, we're going to see if we can find the maximum or the minimum of this graph. So it asks you to determine the coordinates of the vertex. Zoom 6 is always a nice way to start. State the appropriate window setting for the display of the graphing calculator. Well, as long as I can see the vertex, my calculator window looks fine. So the window setting I have now is zoom standard, negative 10 to 10 by a scale of 1. So we're fine. All right. Part B asks you to determine the coordinates of the vertex. So to do that, we're going to go second function, calculate. And this parabola opens up, so I'm no longer looking for a maximum, I'm looking for a minimum. So now we're going to go down to number 3. What's the minimum value? That's where the vertex is going to occur. And it's the exact same thing as last time, left boundary, right boundary. So let's move our cursor until I am somewhere left of that lowest point. You can see the cursor blinking. I am now left of the vertex. Press enter. The little arrow shows up for our left boundary. Now it wants the right boundary. So as long as I get right of that minimum point and press enter, I can now find the lowest point between those two boundaries, which I've identified as my vertex. I don't have to make a guess. I can just press enter. There we go. There is the coordinates of a vertex, 3.25, and y equals negative 6.125. And the neat thing about that is maybe you don't want to put that in decimal form. We will, positive 3.25 and negative 6.125. So the vertex occurs at 3.25 and negative 6.125. But what if we want to be more accurate and put it in fractional form? All right, let's go back to our calculators. These values for x and y are now stored in the calculator as those values. So if I go second function, quit and get out of there, if I just hit x and press enter, it's got that value in there, 3.24999 and so on. If I want to turn that into a fraction, right? Math fraction. Let's see what we get. So 3.25, as a fraction. And we get 13 over 4. And if you go alpha y, right there, and it's got that value, negative 6.125, and if you go math fraction, they'll tell us that value is negative 49 over 8. So we could change these values into fractional form, 13 quarters and negative 49 eighths. 13 quarters and negative 49 over 8. All right, just a little side note if you want to put that into fractional form. Part C. Explain how to use the coordinates of the vertex to determine the equation for the axis of symmetry of the graph, and then state the equation. Well, the axis of symmetry will have to always go through the vertex. All right, so as the axis of symmetry, must go through the vertex. And it is a vertical line. The equation will always be x equals, and this point will be the coordinate, the x coordinate of the vertex. So that's always going to be the equation for the axis of symmetry. So for our equation for the axis of symmetry in this graph is x equals 3.25. All right. Determine the x and y intercepts of the graph. All right, let's go back to our graphing calculator and find those. So go to graph. We're now looking for the points where it crosses the x-axis, and we can't see the y-axis on this graph, but the point where it crosses the y-axis up there. All right, so we're looking for those. Now, these x-intercepts in our calculate menu are called zeros of the function. So second calculate, we're looking for number 2, the zeros of the function. All right, those are going to be the same as your x-intercepts. All right, so you're going to scan and hit number 2, scroll down, or number 2, and again, it's going to give you boundaries. You want to get left of that x-intercept. As soon as I'm left of it, I can press enter. Now get right of it, press enter again, and you don't have to make a guess because you've made good boundaries. So one x-intercept is 1.5. Do it again to find the other x-intercept. So second, calculate the 0, number 2, and again, you must get left of this x-intercept. So I'm now left of the next one, press enter. I now want to get right of it. Good, I'm right of it, press enter. Don't have to make a guess because I've made good boundaries, and that x-intercept occurs at 5. Now how do you find a y-intercept? All you do is hit your trace function, and in your trace function you can let x be any value you want. To find the y-intercept, x is always 0. So if you type in under the trace menu and just hit the number 0 and press enter, it'll tell you the y-intercept. In this case, the y-intercept is 15. That occurs when x is 0. All right. So we found out that the x-intercepts are at 1.5 and 5, and the y-intercept is equal to 15. Using the x-intercepts, verify the equation for the axis of symmetry. So we said on the last slide that it should be halfway between these two. So in other words, we're just finding the average. So 1.5 plus 5, divide that by 2. So that's 6.5, divide that by 2, and you get 3.25. That's the equation for the axis of symmetry. Beautiful. State the minimum value of the function. So if we go back to the graph and look at the vertex, we know the coordinates of the vertex were at 3.25 and negative 6.125. Well, the minimum value is the y-coordinate of the vertex. So that min value is equal to negative 6.125. Right? Look at the graph. This vertex occurred at negative 6.125. That's the lowest value on that graph. Finally, state the domain and range of the function. So domain, we're looking for how far left and how far right. This graph goes forever left and forever right. So our domain, x is any real number. And for our range, this graph goes forever up and forever up, but never, ever, ever below the minimum value of negative 6.125. So I would say my range is y must be greater than or equal to negative 6.125. And y can be any real number as long as it's greater than that. All right. Determining the vertex given the equation of the axis of symmetry. So the coordinates of the vertex of the graph, a quadratic function, can be determined from the equation of the axis of symmetry if we are given the equation of the quadratic function. So the line x equals 2 is an axis of symmetry for the graph y equals 4x squared minus 16x minus 9. Without using a calculator, algebraically determine the coordinates of the vertex of this graph. So if x equals 2 is the equation for the axis of symmetry, therefore 2 is the x coordinate of the vertex. So we already know the vertex has the coordinates 2 and something, but we're not sure what that y value is. So if I know what the x coordinate is, I can plug it into the equation and solve for y. So we go at x equals 2, let's find out what y equals. Y equals 4 times x squared minus 16 times x minus 9. Well, I know the coordinate of x is 2. I can find the corresponding y coordinate, so I substitute 2 in for x. So I get y equals 4 times 4 minus 16 times 2, which is minus 32 minus 9. So y equals 16 minus 41. And 16 minus 41 is a negative 25. So we know the vertex should be at x is 2, y is negative 25. All right. Excellent. Next page. Let's investigate the parameters of a, b, and c in y equals ax squared plus bx plus c. Consider the equation y equals ax squared. State the values of b and c. Well, if y equals ax squared, there are no b and c values, right? B and c are gone. So if they're gone, that means b must equal 0 and c must equal 0. All right. Investigate what happens to the graph of the function when the value of a is changed. Use both positive and negative values for the parameter. Write down your observations. Okay, so let's do this. So this is a website on the internet. Helps us explore this the parameters of this parabola. So copy and paste that into a web browser, and we get this nice quad function explorer in standard form. So y equals ax squared plus bx plus c. All right. They told us to let b and c equal 0, so we've done that, and a is 1, and they wanted us to investigate what happens to the value of a. So let's see what happens if I make a positive. We're going to move this slider up. A is 1. as A gets increasingly positive, what's happening to that U-shaped curve? All right. As A starts going negative, so let's say A is 0, we got a nice straight line. Now when A starts going negative, it's going to open down.
Could you please go to the cafeteria?
And as it gets more negative, it gets narrower and narrower again. All right. So it's just getting narrower, 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 but now it's opening down. So when it's positive, it opens up. As A increases, it gets narrower. As it's closer to 1, it gets wider. Look at what happens when A is 0.2, very wide graph. When A is negative 0.2, it's still a very wide graph, but now it opens down. And as it gets more negative, it's still opening down, but it's getting narrower and narrower. All right? So let's write that in right here as, let's just say, if A is positive, the parabola opens up, and if A is negative, the parabola opens down. What else do we notice? Absolute value of A increased, the parabola got narrower. So absolute value means whether A is positive or negative, once A started increasing, right? Whether it was negative 10 or positive 10, the parabola kept getting narrower and narrower. All right. Let's see what happens if we investigate when A is 1. So what are the values of A and C? Now A equals 1 and C equals 0. So let's look at what happens if we have A equaling 1 and C equaling 0 and change the value of B and then write down our observations. So let's do that. So A should now be 1, positive 1, and C is still 0. Let's slide B around and see what happens. So if B becomes positive, it's going to move down and to the left. Interesting. And the graph seems to be getting a little bit wider as well. If B is negative, it's going to move down and to the right. And the graph seems to be opening up. Okay. So again, as B is positive, it moves left and a bit down. When it's negative, it moves right and a bit down. All right. Let's write that observation. As the B value increases positively, the graph moves left and down. As the B value decreases negatively, the graph moves right and down. Third investigation. Consider the equation y equals x squared plus c. What are the values of a and b? A equals 1. B equals, there is no b value, so b is 0. Again, let's investigate what happens to the value of c when a is 1 and b is 0. All right, so a is 1, b is 0. Now it's not moving right or left at all. The b value won't make it move right or left. So what happens to the graph when we move the c into a positive direction? Oh, now the graph moves almost exclusively up. And when c goes negative, it moves exclusively down. All right, interesting. So positive c values make it move up. Negative c values make it move down. All right. Okay, let's write that down. When c is positive, positive, the parabola is above the x-axis, and when c is negative, the parabola is below the x-axis. Very good. All right, summary of the characteristics of the graph of y equals ax squared plus bx plus c. So the graph of a quadratic function defined by this equation has the following characteristics. Fill in the blank to complete the summary. All right, so let's fill in this blank. Fill in all the blanks. The shape of the parabola is a parabola. The graph is symmetrical about a vertical line. That vertical line is called what? The axis of symmetry. If a is greater than 0, that means it's positive. The parabola opens up, and the vertex, therefore, is a minimum point. The y-coordinate of the vertex is always the minimum value of the graph of the function. If a is less than 0, the parabola should open down, and the vertex is the maximum point. The y-coordinate of the vertex would then be the maximum value of the function. The domain of the graph, every parabola goes forever left and forever right, so the domain of the graph is always x is any real number. If c is greater than 0, meaning the graph's going to move up above the x-axis, then the graph must have a positive y-intercept because it's above the x-axis. And if c is less than 0 or negative, then the graph will move below the x-axis and has a negative y-intercept. All right. So you've got your diagrams of these important information. Well, you will complete questions 1 through 6.